Alright, so we've gone up the elevator in FBAT, and we're here at the lab for that has our X-ray diffractometers. So if you can I just wanted to show you what this would look like. We're going to do this again in MSE408, but I just thought I'd show you where it's at. So as you can see from the door, X-ray diffraction goes on here, and so I'm going to unlock this, and we're going to go inside and run the X-ray diffractometer. Alright, we are here in the X-ray diffractometer lab. This is the machine that the undergrad lab has. It's a Siemens diffractometer. So this is what it looks like. It's a cabinet style, so there's a safety door here that if the x-rays were on and I open this, it will stop the x-rays. So what I'm going to show you first is how to start this up if you are the first user to use the X-ray diffractometer in a day. So all the instructions for power up and also power down are here on this piece of paper that Nancy has made for us. And so I'm just going to kind of go through this and show you the startup procedure. So the X-ray diffractometer is always running. We never have it off unless we're servicing the instrument. And so it is on. It's just in a sort of powered down state. So the first thing I'm going to do from the sheet here is there is a voltage setting and a current setting. So here's our voltage in kilovolts and our current in milliamps. And so right now the current is 5 milliamps and the voltage is 20 millivolts. So you can read it here, and there's also a readout up here. So this is 5.1 milliamps, and if I hit this button, it's telling me it's 20.0 kilovolts. So the first thing we want to do is we want to raise the voltage from 20 to 40. And so everything we do here, we're going to try to do it relatively slowly so we don't sort of shock the system. So I'm going to depress this voltage button just so I can read out this voltage, and then I'm going to turn this knob down here slowly until I get up to 40. So 40 kilovolts is the operating voltage that we use for this machine. Alright, so it is 40.0 kilovolts, so we're good on the voltage. So that's the first step. Now we're going to raise the current from 5 up to 30 milliamps. So that's reading out right now, and so I can slowly again rotate this until I'm up at 30 milliamps. Alright, it's reading 30.0 milliamps now. So this is the power up procedure for this X-ray diffractometer. So we're all set to load our sample and go from there. So we'll take a brief pause and then come back for sample loading. Alright, we are here to now put in the sample into the X-ray diffractometer. And so I want to bring your attention to some safety stuff first. So like I mentioned briefly before, this door is rigged so that if I try to open it when the X-ray beam is on in the chamber, it will shut down the system. And so typically we don't want that to happen, but it is a safety mechanism that's built into this machine. So it's a very safe machine. So when I'm ready to load my sample, what I want to do is make sure the X-ray beam is off or the shutter is closed. So if you sort of come over here, you see that these are our buttons for the shutter. You'll see open up here and shut. So this is the X-ray beam shutter. And so if I'm going to get into the chamber, I want to make sure that it's shut. And so every time I'm up here, I'm going to make sure that that's shut. So I'm always going to hit the button And so one thing you'll notice and how you see if it's actually on is there's inside there you can see shutter open if lit. So there's a light there. And so the shutter is open right now. So I'm going to hit the button right now, and that light should go off. And you should hear a little click maybe. And so now I know it's off. And so you always want to make sure that light is off before you open the door. So now it's safe to open this door. We won't have to activate the safety features, which is sort of a last case resort. And so I'm going to go ahead and open it. All right. So now you can sort of see inside the chamber. So the what we have here is the X-ray beam. We have the sample holder, and then the detector up here is part of this rig. So we have the sort of the setup for Bragg geometry happening inside this machine, and then we're measuring the angle with the readouts down here. All right. So what I'm going to do is I'm going to grab my sample that we made. This is actually Wednesday A's powder, so we've switched over from Nancy's. And so I'm going to put this in the machine with the powder towards the back and the label towards the front. And so I'm going to go ahead and put it in this slot here. And you might have to wiggle it around a little bit. All right, so it's all the way back as far as it can. And so now, so it's all the way back in the right position, but we need to set the depth. And so one way we can do that is also make sure it's secure, is this piece down here. And so by pushing this up, it locks the sample into place and makes sure that the sample is flat. So now by pushing this up, that allows us to lock everything in place. And so now this is perfectly flat and in plane with the Bragg geometry. If I wanted to remove the sample, which will show the procedure, there's a little button here that I can press to get the sample to come out. All right, so once everything is set up and ready to go, we're going to close the door back up. All right, make sure it's closed. And then now, obviously, if we're going to do X-ray diffraction, we need an X-ray beam. And so you always want to make sure that after you have the door closed and you're all set to go, that you open it back up and make sure that light's back on. So this will allow us to do the test. If that is not open, then obviously there's no X-ray signal, and so your run will be worthless. And so, so that's how you load the sample in. And then we will set up the computer to run the run for us. So we'll come back in here in a second and show you that. All right, we are back here. We're at the computer that controls the X-ray diffractometer, and I'm going to show you how to get this set up to run the XRD program. So the first thing is we want to go here to the desktop where our program is here. This is I don't know how you say that, but VisX DACO maybe? That sounds good to me. So we double click that if it isn't open already, but we have it open. So I'm going to open up down here. So this is the software that controls the diffractometer. And so the first thing I'm going to do is save it with a name. So like I said, this is the Wednesday A's sample, and it's been calcined. I've abbreviated things because it doesn't accept long file names, and it's going to save it as that .cpi. So this is the proprietary software file format that it has. And so for us, the standard run is going to be from 10 degrees to 100 degrees. That's the scan range. And then we're going to have a step size of 0.02 degrees, and it's going to scan at a speed of 1 degree per minute. And so that's the standard scan we will have. If you want to add any comments about your sample, because the file name is so small, you can do that here in the comments. And so that's what we'll need to set this up. So now I want to draw your attention to the board. So Nancy has saved a lot of information for us so that we, in case we forget. So down here at the bottom, you'll see this sort of standard scan conditions. So just in case we forget, it's there. And then also at the top is the wavelength. So this is the wavelength of X-ray radiation that we're using for this experiment. And so this is what we have for our experiment. So this is the one you'll want to use. In the data file, it may give you something else, but make sure you use this value. All right, so when we are ready, we are going to hit Start Scan. And then it's always going to say that it's overriding this file, so we want to say yes. You might hear the machine in the background. It's moving to go to that 10-degree scan. So you can actually see what's called the goniometer moving, the thing that controls the angle, moving there in the background. So it's going to start at 10 degrees, and then it's going to go up to 100 degrees during the scan condition. So when this gets set up at its initial condition, I'm going to draw your attention to the screen here. All right, it's just started. This is the graph. It's going to be in terms of the angle to theta at the bottom and the counts. And so we want to stick around here until we at least see something appear. So right now, I just saw something appear right here. So I know that I'm getting some small level of counts, about 100 counts. So that means that my X-ray shutter is open, and so I'm actually getting X-rays. So you want to always stick around and make sure that that happens. Otherwise, the scan's going to be kind of useless. Here at the bottom, it'll also show you what angle we're at and what the counts is. And then this last part, which is the most important if you're going to be in the lab and come back, it says that there's an hour and 29 minutes left with 10 seconds. So this tells us when we basically need to come back to check on the scan. So we're going to leave this alone, let it scan, and then in an hour and a half we'll come back and show you the shutdown procedure. All right, we are back here. The scan is done for our XRD run. And what I want to do now is show you how to take your sample out and then shut down the machine for the next user. We don't actually shut down the entire machine. We just put it back to its original settings because if we have the cooler and things off, then that takes a long time to restart. So we actually leave it on all the time except we turn down the current and voltage. So I'll show you how we first take our sample out. So as you might be able to see up there, the light is on, the shutter's open. That means that X-rays are in the chamber. So we don't want to open this if possible. So we're going to come over here. We're going to find the shutter and we're going to shut it. You should hear a click and the light will go off. This means it's safe to open the door. So I'm going to open the door. And I want to take my sample out. So I'm going to hold on to the glass, and then I'm going to hit this little lever over here, and that's going to release it. And so then I can just take it out. And so I'll put that in my container. It is ready to go now. I'll shut the door back. I'll leave the shutter off. If you turned on the light or anything, you can switch that off so that it's not constantly running. And then what we're going to do is lower the current and voltage in the opposite direction that we did before. So let's see how that works. All right, so these are the conditions that you've seen before. So right now, it is set on 30 amps. If we switch over, it's set on 40 volts. So we're going to do this in the opposite order that we did to start it up. And it's also, the instructions are on this piece of paper here if you're in the lab. So what we're going to do is lower the current first. So the current is at 30. We want to lower it down to its maximum, and we want to do it slowly. So opposite direction, you'll see that the value here is slowly going down. And I'm going to do this until I get to the end. All right, once I get to 5, it is at the lowest current possible. So I've done that step. Now I'm going to lower the voltage. And so if I want to see what the voltage is at, I hold this button, and it's at roughly 40 right now, and I'm going to lower that down to 20. All right, it's at 20. I can release that, and this is this stage we're going to leave it in for the user. So we're finished with. Put this back up for a second. All right, so we're finished with taking our sample out. We've done the run. We've left the instrument for the next user, and so the last thing I'm going to do is show you the software up here that we can do some of the initial peak fitting and analysis. So that's what we'll do next.